Hello everyone, I'm Jonathan Flores and this activity belongs to the subject of CMOS Digitales. In this video, I will explain the design and simulation of a fin state machine used to control a stepped motor, implemented in VHDL and simulated using Cuesta. This project allows the motor to rotate step by step in either clockwise or counterclockwise direction, depending on a control input signal called dir. So first, let's start with the VHDL code, named motor control. In the entity, we define the input clock 50 MHz, a reset signal, reset clock, a manual reset, the direction input dir, and the 4-bit output motor which drives the stepped motor coils. There is also an output clock out, which corresponds to a divided version of the main clock. Inside the architecture, the FSM is declared with 8 states from 0 to 7, each representing one step in the half-step sequence of the motor. A 26-bit signal named clock temp acts as a clock divider. On each rising edge of the 50 MHz clock, it increments it an bit of 16, that is like new, becomes a slower signal that controls the timing of motor steps. The FSM logic is implemented through two main processes. The first process updates the current state, that is PR state, on every rising edge of clock new, or reset it to 0 when reset is active. The second process defines the next state and output behavior. When dir is equal to 0, the motor rotates clockwise, following the sequence of code activation. That is 1, 3, 4, 5, 6, 7, 8, 9, and back to 1. When dir is equal to 1, the other reverses, producing control-wise motion by inverting the transition sequence. This structure ensures smooth and accurate bidirectional rotation of the stepper motor. Now, let's go with the VHT. And the test bench named motor control VHD is where all the signals, clock reset, direction, and motor outputs are declared and connected to the main design instance. Okay, now we have our FPGA board function, and we press the third switch to stop. Now we can see that we can stop the clock, and we can do the reverse for the motor, and we can stop and start again and stop the clock again, and that's it. Thank you so much.